Well, congratulations, you made it to video Z. I don't usually have this many videos. This is just kind of a big section. Okay, so we're going to do some multiple transformations given a graph. So what I like to do when I have something like this is look at the function and see what transformations are going on. Now, you could do this with a table, because you might be wondering, hey, could I just use a table like the last one? You could do it that way. We usually do it in a picture form, like in a graphing form. What I'm going to do is do all my work on this grid that I have here, and then I'll put the final answer on a different grid. Okay, the first thing I would do, though, is I would rewrite this with that factoring. Remember, we talked about factoring out b? Okay, so I would do that first right off the bat, and you can check and make sure if it distributes that it's the same as the original, and it is. And then I would think in terms of the horizontal transformations and then the vertical transformations. It looks like we have a horizontal stretch, right? And then we have a horizontal shift. And that's going to shift to the left. And then finally, that's going to be the +2 part, right? Okay, so that's 2 units to the left, okay? And so you might want to say -2 there if you want to think about it that way. The stretch, by the way, it's going to double, so it's going to be 2 times. And then finally, we're going to have a vertical shift down 3, okay? So I don't like my left -2. That's confusing. So it's left 2, down 3. Okay, that might make more sense. Make it easier to understand. Okay, direction, right? Okay, so I'm going to start, I'll start with green. I'm going to do a horizontal stretch. Okay, so a horizontal stretch, what does that mean? It means that this point's going to stay the same, my 0, 2. It means my 2 is going to go to 4. Oops. And my -2 is going to go to -4. So it's like an accord or like a slinky, you're pulling it apart. Okay, so I'm going to try to make this curve as best I can. Okay. So that represents the horizontal stretch. Now, we have not had examples before where we were stretching both to the left and the right. So you have to think of it like a slinky that you're pulling apart, okay? You could put in numbers and you could play around with the table, you know, and see if that makes more sense to you. But what are you doing? You're putting in a 2. It's going to be a little hard to see because you have to pull apart just that one piece. So you have to say, I'm just doing f of 1/2 x. That's the first part I'm doing. Okay, so when I put in 2, or when I put in 4, I get f of 2, which happens to be 0. And then you could go through it like that. Okay, now I'm going to switch to a different color. And we're going to do a shift left. So all my points need to go 2 units to the left. So I'm off the grid here. 2 points over that way, 2 over that way, and then 2 over that way. And the shape is going to maintain the same. Well, try to maintain it the same. Okay, then that represents f of 1/2 of x plus 2. Okay, that represents that part. Okay. Now we just have to do one more thing. We have to take it down 3. So it's the whole thing's going to shift down 3. And so I'm going to take these points. I'm going to have 1 here. I'm going to have 1 here. And I'm going to have 1 here. Ah! Oh, no, I picked the wrong point. Darn it. Okay, well, that happens sometimes. Let me get that out of there. Okay, so I think I got the first 2 points. I was trying to use orange and I accidentally went to green. Okay, so down there. Okay, draw the shape as best as you can in this case. Okay, and so that would be the answer. this then is k of x. And I'm not going to transfer it to another graph. You could run a table and see, if these are matching up. Like if I put in, it looks like -6. I'll try one here. So k of -6, it's f of, and I'm going to, this one right here, 1/2 times -6 plus 2 minus 3. What happens? F of 1/2 of -4 minus 3, or f of -2 minus 3. Now you have to go and see what was f of -2 originally. Okay, originally it's that point right there. The output was 0. So now I'm having 0 minus 3, which is -3. So I'm saying there's a point that if I put in -6, I get out, input -6, I get out a -3. Is that true on my graph here? Is that point right there, -6, -3? And it is. And you could check this by going through the other points, but I'll let you do that on your own. Okay, but we got it graphed, and that's what we wanted to do.